Hello and welcome to this WebEx posting video. This is the fifth WebEx posting for Senior Design 2, and this is the WebEx posting that is due Friday, April 11th, 2014, and it's the WebEx posting for the Temple University NASA Lunabotics 2014 Electrical Senior Design Team. My name is Mark Halberstadt, and also with me is John Morris, and also working on the project is Eric Schisselbauer, and our advisor is Dr. Helferty in the Department of Electrical and Computer Engineering. So what I want to do in this presentation is, just like always, go over our electrical team goals, highlight the progress that we have made since our last WebEx update, and then talk about what the next steps are for the project. So, as always, our electrical team goals are design and build power, control, and communication systems capable of piloting our Lunabot. And we are pretty confident that we have made very significant progress towards this first goal. This second goal, complete autonomous functionality of the mining vehicle, that has really been our focus really for the past couple of months in this project. And hopefully you'll see in this presentation we are well on our way. We are actually doing our first full-scale autonomous test tomorrow. I'm recording this on Friday, April 11th. We are doing our first full autonomous test tomorrow, Saturday, April 12th. And then the third goal is increased power efficiency of the system in order to reduce the size of all the electrical components and the weight of all the electrical components, most notably our battery system. So the progress that has been made since the last update has to do primarily with our new 3D printed beacon pole. A couple of things which have happened is that we have really finalized the 3D print of the beacon pole. We've actually integrated in some visible LEDs into the beacon pole, which John is going to talk about. We've also integrated the compass into the beacon pole. This is really important because the compass is a very integral part of our autonomous system. We need to know what heading angle the direction the robot is facing. We have also finalized what we're calling our beacon controller system, which is able to take 5-volt logical input, or also 3.3-volt logical input. We've tested it with both. From a typical microcontroller, we are using an Arduino that's able to take that 5-volt logical input from an Arduino microcontroller and use that logical input in order to trigger the LEDs on our beacon, which are running at our battery voltage of 25.9 volts. So we have finalized that controller system, and it is also put inside of a 3D printed box. We have also completed the implementation of the autonomous system finite state machine, which I'll go over a little bit later on in the video. So now what I'd like to do is I'd like to show some photos of the beacon to start off with. I just want to show a photo of the compass integrated into the beacon. So this is our compass is going in the top of our beacon pole, and it's hard to see in this photo, but there is an indentation which is made for this beacon. And as you can see, the wiring is nice. We've glued the beacon in, and we've only glued it in on one side, the same side as the wiring, so we can still pull the beacon pole apart. Now I guess what I'd like to do is, I guess John can talk about the visible LEDs and also the beacon controller box.
All right. So the next one here.
Oh yeah, sure. Which one?
All right, let's go next.
Like this one?
Yeah.
Okay.
So right here, you see I'm working on the beacon control box. Basically, there's a circuit board in here that has a whole array of transistors and resistors and other components that really control. It actually regulates. Like if you apply a 5-volt signal to one of the transistors, it'll allow you to pass through the 26 volts, which is required for the each strand of LEDs to work. You get the next one. Mm-hmm. And then also in the top here, you can see the punch blocks are basically they're like female connectors for Ethernet cable, Cat5 cable. So that's what we're using to just plug in the beacon pole and also the Arduino to this control box.
Mm-hmm. And this is basically another photo of the same thing. We should also mention that This is actually a wall plate for these 4 Ethernet punch blocks that we have here, and we have actually 3D printed an enclosure that this wall plate fits pretty precisely onto. Yeah.
Yeah. And if you want to go to the beacon pole.
Sure.
So basically on the other side of the, or on the part of the beacon pole here, there's some top rings like we said last time, and then we have the 14 channels around the side that go straight down. And the 14 channels is what right now is going to be plugged into the control box, and then later we plan to get the top rings plugged into it as well. Mm-hmm. And also we finalized getting on the visible LEDs. There's all the LEDs on there are infrared except for the bottom LED on each strand, which actually lights up red. That way we can see which channels are actually on.
Mm-hmm. Great, thanks. Yeah. So anyway, that's I guess everything I wanted to go over with the beacon pole, kind of the big things we've been working on. Next, I guess what I want to go over is just kind of our high-level state machine. This is actually the same slide that we presented at our final Senior Design 1 presentation for the high level of our autonomous state system. And this has really been the focus of the autonomous system. We are gearing up. Tomorrow is going to be our first full-scale autonomous system test. We have been, I guess, cleaning up the implementation of this state machine. The state machine has become a little bit more complicated than what we have shown in this state diagram. But it is still basically the same exact thing. There's an init state. We currently wait for a start signal, and the start signal is actually going to be sent by our manual control system. One of the things in the NASA rules for the competition is that the way NASA essentially defines autonomous functionality is that no team member is allowed to touch any of the electronics that are in communication with the robot. So, that's the way essentially NASA makes sure that no one is sending any controlling information to the robot. In order to, I guess, obey those rules as faithfully as we possibly can, what we are doing is we are actually going to implement our own countdown system for the autonomous system. So rather than pushing a start button, so in this init state, we go right from the init to a wait for start, and then once we receive a start signal, we start driving to our dig start target. Instead of having this start signal be manually activated, what we are actually going to implement, and this is implemented in our manual control system, is this is actually going to be a countdown. So we are going to count down approximately about 1 minute. We're going to start a 1-minute countdown, most likely when we have 50 seconds to go before the round starts. That way, we are able to, we essentially have a 10-second buffer. We are going to effectively wait 10 seconds once the round actually starts, just to make sure that we are in full compliance with the NASA rules. But basically, our autonomous system is, once you get the start signal, you start driving towards your dig target. Once you reach that dig start target, you start your collection system going. Once you start your collection system going, and the way our robot works this year is our collection system is actually going to activate and start collecting material, and then drive to what we're calling our dig finish target while we're collecting that material. Once we reach that target, we have actually added steps in here such that we can complete multiple digging iterations on each trip out to our digging area. But essentially, right now, what happens is we stop our collection conveyor, and then we drive to our dump target, which is right next to our collection bin, dump into the collection bin, and then restart the cycle over again. If at any point we receive either a manual control signal or a stop signal, our autonomous system will immediately go to the respective state. And that's essentially what has been the main focus for the autonomous system, has been actually implementing all of this logic. For our next steps, for our power system, as I said, we are doing our first, we're doing a pretty big test tomorrow, April 12th. And it's actually the first test where we are going to be integrating in a motor into our dumping system. This motor is actually quite a bit more powerful than the motor we, I guess, originally intended for. However, it's still, based on the data sheets that we have for this motor, still should be within the spec of our power system. Our power system should be able to support that motor. However, what we do need to do, we do need to make sure that we are measuring the power being consumed, in particular by that new dump system motor, just to get an idea of how much power that motor is actually, how much current is actually running through that motor. For the communication system, we are going to integrate network communications into the existing autonomous system. Sorry, I didn't finish that. We're going to integrate pretty much network communications are almost completely done, which is going to be moving information between our location system, the autonomous system, and the command center. We are going to be integrating that communication into the existing system. And finally, for the autonomous system control, we are basically going to be integrating the entire system together. And I guess for our schedule, today is April 11th, so we are going to be testing on April 12th. So April 12th is going to be our first autonomous test run. And that is kind of the big thing coming up on our schedule. Really, the entire rest of the project is going to be driven by the results we see at this test. So we're not anticipating any redesigns. However, we do have time. If we have to do some type of redesign, we are going to be making those decisions pending how this test goes. So anyway, that pretty much concludes this WebEx presentation. Thank you so much for watching. And if you have any questions, please feel free to leave comments in the videos or shoot me an email at c.mark.halberstadt@temple.edu. Thanks so much for watching.